Hello everyone, I am Dr. Abha Kumari. Today we will discuss some another definitions from graph theory. So our next definition is simple graph. So first we understand what is this simple graph is. A graph in which is free from any loop or multi-edges is called a simple graph. For example, if we have a vertices like this, okay, and we now join these vertices this way, and again in this way. Okay, fine. So what we see here is there any loop seen in this figure? No. So there is no loop in this figure. Also, is there any the parallel edges or multi-edge? Multi-edge we have learned in the previous lecture. Multi-edge means in which from the two vertices we can draw more than one edge is known as the multi-edge. So here we have one edge, and again we have only one edge, but the no more than one edge is seen in any pair of vertices. So this type of figure is known as a simple graph. So here we will write a graph which have neither parallel edges. Parallel edges is also known as multi-edge. Edge. Okay. Nor self loop is called simple graph. Fine. Okay. Now next definition. So our next definition is multigraph. Multigraph. So a graph which contain parallel edges. Okay, here neither parallel edges, but in the multigraph we have parallel edges as well as self loop is called multigraph. Okay, so the another definition is directed graph. So what the directed graph is? A graph G. So a graph G, VE, V is vertex, E is edges, is said to be directed graph if it is required to associate a direction with each edge. Associate our direction with each edge of the graph G. Okay. For example, if we have a directed graph, so our directed graph on V equals to V1, V2, V3 and V4. Okay. And the relation given us, and the relation is like V1, V2, V2, V3, V3, V4, V1, V3, okay, and again we have V1, V4, V2. So we have the 4 vertices 1, 2, 3, 4, and we have taken the relation like v1 to v2, v2 to v3, v3 to v4, and again from v1 to v3 and v4 to v2. So let us draw the graph of the following. So we have here is v1, now then v2, okay, then v3, and then v4. So first relation is from v1 to v2. So v1 to v2. So the direction is like this, from v1 to v2. So this is known as a directed graph. So here it is associated with v1 to v2. Then again we have v2 to v3. So v2 to v3. So from v2 we move to v3 and give a direction like this. Again we have v3 to v4. So v3 to v4 and direction is up to v4. Next is v1 to v3. So v1 to v3 in this way. And lastly we have v4 to v2. So v4 to v2. So in this such type of graph is known as a directed graph. Here in the degree, so from this directed graph we can define the in degree and out degree of a vertex. So let us see what is in degree and out degree. So in degree, so here in this figure, in degree of a vertex V in a graph, so here in this figure, in degree of a vertex V is the number of edges ending at it, fine, and is denoted by in DEG and then bracket G, fine. Similarly, the out degree. So what this out degree is? The out degree of a vertex V, okay, in a graph is a number of edges beginning from it. It's a beginning from it, right? And is denoted by out degree. So here in this figure, let us see what is the table for the out degree and in degree. So let us consider the table for this figure. So here is our vertex v1, v2, v3, and then v4. Right. Here is our in degree. Next is out degree. So what the in degree here in this figure is from v1. So how many in degree in v1? So here we see that in this figure from v1 we can out to v2 and again we out to v3. But here we are not coming from any vertex to upward v1. So here in degree v1 is 0. And how much out degree? So from v1 we are going to v2 and again to v3. So out degree is our 2. Now for v2, here for v2 in degree is 2 because from v1 we are coming to v2, from v4 we are coming to v2. So here in degree is 2, while the out degree from the v2 is only 1, that is v3. So out degrees are 1. Again for v3, what do you see that in v3? For v3 we have both in degree and in degree. So V3 having 2 in degree, and our degree is only 1. For V4 we have in degree, so we are coming from V3 to V4 and again go out V4 to V2. So in degree is only 1 and our degree is also 1. Okay, so this we can write the in degree and out degree of a graph. Right. So let us see the next. We have degree of vertex. So what are the degree of vertex?